Okay, let's look at how to do figuring out the reaction order when you have a more complicated problem. Now, on a previous video, I did this problem right here, and we were trying to get the reaction order. Now, you can get it from the slow step or the rate determining step. That's how you can figure out the reaction order. You can get it from the rate determining step. Now, what you have to do is make sure that in the rate determining step that the order that the compounds or whatever in the rate determining step match the ones in the overall equation. And you can see that HCl is HCl and C2H4 is C2H4. So what you were able to do for this one on the previous video, we were able to just say that rate equals K, and then that would be C2H4. Now what you do is you look at the coefficient in front of C2H4. So if it's in the rate determining step, that's going to be your exponent. So it would be 1. Now normally we don't write 1. Then HCl would be 1 also. Okay, and that's how you would figure out the the rate law. You can get that from the rate determining step as long as those things match. Now here's an example I want to show you where they don't match. This one's more complicated. So what you're going to do is you're going to write the rate law for this one. And so you look at this, you look at the slow step and you say, okay, CH4 is here and CH4 is up here, so that's good. Here we have Cl2 and here we have Cl. That's not good. Okay, so that means we have to do some other steps here. Alright, so you can write it from the slow step, and so that's what we're going to start off with. So what we're going to do is we're going to write it for the slow step. So we're going to start by going rate equals K, and I mean you can do you can label all these arrows, like that would be K1, that would be like K minus 1. Sorry, that isn't writing very well. This one right here that we're doing right now would be like maybe K2. So what you can do is you can say rate equals K2. Okay, the numbers on the K's don't really matter. And then you're going to write CH4, and notice that CH4, there's just a 1 in front, so it's CH4 and then Cl. Okay, but the problem is the rate law has to match what's in the overall equation, and see how Cl doesn't match Cl2. This Cl2 is diatomic and this one's not, so that's not going to work. Okay? So what you have to do is you have to go to the fast equilibrium, and that's this top one right here. And I tried to label it K1 and K minus 1. And so the K's don't really matter that much for this thing right here, but let me just write this out. So you're going to take the fast equilibrium, so we're going to take the fast, and we're going to write it like this. That rate, okay, going the forward direction is going to equal K, and we'll just call that K1, and we'll go to Cl2, like that. Okay, but because it's an equilibrium, the reaction can go both ways. That's also equal to K negative 1. Okay, don't worry too much about these, or not K negative 1, K1 or K negative 1 should be down here. Don't get caught up with the K values. They're not that important for what we're doing right here. So we have K negative 1 here. Okay, and then we're going to multiply that by what's right here. We have Cl, and that goes to the second power. Now we can write that down here, and basically what we get is that the rate going one direction with Cl2, that's going to be equal to the rate going in the opposite direction. Okay, so the negative 1 just means it's going in the opposite direction. Okay, and that's Cl to the second power. Now what we can do, if we can figure out what Cl is equal to, we can substitute that value in up here in this rate law. So what we're going to do is we're going to do a little bit of math here, and we're going to divide both sides by K1. Alright, so what we're going to get after we do that, we'll get K1 over K minus 1, okay, times Cl2. That's going to be equal to Cl chlorine to the second power. Now, we're going to take the square root of both sides. Alright, so we'll take the square root of this side, and we'll take the square root of this side. And so what we get after we do that is we get K1 over K minus 1, okay, and then we have Cl2, alright, and those things, this whole thing, all of this stuff is to the, well, we can just do it like this. I'll put the k's in parentheses. They're to the 1/2 power because we took the square root of them. And so the Cl2 is also to the 1/2 power. Now what that's going to be equal to is Cl over here. Now, see, now we know what Cl is equal to. So we can take this and we can substitute that in right up here. Alright, so now we can rewrite this one. We can say the rate equals K2. Now, I'm just going to combine all these K's together, okay, times K1 over K negative 1 to the 1/2 power, so all the K's are together. And then we have CH4, it's still good, just how it was before, to the first power, because see, in the slow step, there's no exponent, or no coefficient in front of there. Okay, now I'm going to erase this line, it's kind of in my way here. And so then we have this right here. We have Cl, but we got to write what Cl. I already put the K's up here. So we have Cl2, and that is to the 1/2 power. So identify the order of reaction with respect of each of the following according to the mechanism. So CH4, its order is 1, because in the slow step, okay, you can get it from the slow step as long as it's in the overall equation. And so we know that CH4, we just wrote the rate law actually up above, but it's first order, okay? Now the Cl2, we had to do some tricky things because it's not in the slow step. So what we had to do is, when it's not in the slow step, always go to fast equilibrium, and then you can write the fast equilibrium in terms of what's in the slow step, so you can substitute in, and we found that Cl2 then was to the 1/2 order. And so Cl2, see Cl2 here, Cl2 there. So Cl2 is to the 1/2 order. Okay, now one last thing, I kind of skipped over question D, so let's talk about question D. Let's erase this here. So they want to know, in the mechanism, is CH3Cl a catalyst or is an intermediate? Well, if you noticed, it's CH3Cl is produced in one step, but in a later step it's used up, and so overall it would cancel out. That makes it an intermediate. When something is produced in a previous step and used up in a later step, that's called an intermediate. So that's why that's called a catalyst. Okay, I hope this video helps you out here, and hopefully you can figure out what's going on here with this stuff.